Please confirm if
All good.
the screen is visible. Okay, thank you. Hello everyone, welcome to our webinar today. This is Shabaz. I'm a product manager in the Azure Network Security Customer Experience Engineering team here at Microsoft. Today we will be talking about Azure DDoS Protection Service. Here's the agenda for today's session. We will start with looking at what are the different attack trends and types, and then we will talk about different DDoS protection offerings in Azure. And finally, my colleague Saleem will be taking over and spending some time on the demo. So let's get started. So what are DDoS attacks? DDoS attacks, in other words, distributed denial of service attacks, are a type of attacks which attempts to exhaust the application's resources by sending large amounts of traffic, thereby making the application unavailable to the legitimate users. So why should we care about these attacks? Basically, any public IP that is exposed to the internet is susceptible to DDoS attacks. So if you have any application that is internet facing, you need to make sure that you're protected from these type of attacks so that your application's availability is not affected. Let's look at the recent DDoS attack trends. In 2022, Microsoft mitigated an average of 1435 attacks per day. As we can see, the maximum number of attacks in a day recorded was 2215. We saw a lot of politically motivated DDoS attacks, mainly from a hacking group called Killnet, which targeted Western government, healthcare, education, and financial firms. Out of all these attacks on healthcare were rising evidently. The shorter duration attacks that lasted for less than 1 hour were more commonly observed during this year, comprising 89% of all the attack traffic. As we can see in the last image here, the TCP flood attack was the most common attack, comprising 63% of all the attack traffic. Since TCP remains the most common networking protocol, we expect TCP-based attacks to continue to make up most of the DDoS attacks. Let's go over the different types of DDoS attacks. The first one we have here is the volumetric attacks. These attacks flood the network layer with a substantial amount of seemingly legitimate traffic. Because of this, excessive network bandwidth gets consumed, thereby saturating the network layer, making it non-functional. These attacks are easy to generate, either using DDoS for higher services or with attackers employing simple amplification techniques. These attacks are measured in bits or packets per second, and some of the examples of these attacks are ICMP flood, IPsec flood, and UDP flood. The second type of attacks we have are the protocol attacks, also called as state exhaustion attacks. This type of attacks causes a service disruption by consuming all of the available capacity of the web application or the capacity of the intermediate resources like firewalls and load balancers. It abuses flaws on the network layer, exploiting protocols like IP, ICMP, and IPsec, and on the transport layer, exploiting protocols like TCP and UDP. The most common example is the TCP SYN flood attack. This attack exploits the TCP handshake by sending a large number of TCP SYN packets, also called as initial connection requests, with spoofed source IP addresses. The victim machine tries to respond to each connection request and keeps waiting for the response to finalize the handshake. But this response never comes. All of these requests stay in an open state waiting for a response. This indeed causes the system to exhaust all its resources and become unresponsive. So, like I mentioned, some of the common attack types in this category are the SYN floods, fragmented packet attacks, ping of death, and Smurf attack. And the final type of DDoS attacks we have are the resource attacks, which are also called as application layer attacks. These are layer 7 attacks that target the backend server. The goal of these attacks is to exhaust the resources of the target application and to abuse flaws and vulnerabilities on the application itself. For example, targeting how web pages and web servers handle the HTTP requests. A single HTTP request is simple to execute on the client side, but it demands a lot from the target server to respond because the server likely loads any files, run database queries, etc. This type of attack is a challenge to identify and defend against because the traffic seems very legitimate. DDoS protection by itself does not protect against layer 7 attacks. We must also use a web application firewall such as Azure WAF in conjunction with DDoS protection standard to provide defense against these attacks. Some of the examples of these attacks are HTTP flooding, slow loris, etc. Another notable point here is that we now have date limiting feature in both App Gateway and AFD WAF, which can help with HTTP flooding attacks. Let's talk about Azure DDoS protection now. So Azure DDoS protection comes in two SKUs. The first one is the Azure DDoS Network Protection. It provides enhanced DDoS mitigation features to defend against DDoS attacks. It's automatically turned to help protect your specific Azure resources in a virtual network. It currently covers 100 public IP resources at a cost of $3,000 USD. A single DDoS protection plan can be used across multiple subscriptions under a tenant, so there's no need to create more than one DDoS protection plan. It comes with features like adaptive tuning, attack analytics and metrics, Sentinel and MDC integration, DDoS rapid response, SLA guarantee, and cost protection. We'll talk about each of these features separately a bit later. The other SKU we have is the Azure DDoS IP protection SKU. It's a new SKU that can be directly enabled on the public IP. This SKU is designed for small and medium businesses as it is cost effective and at the same time providing enterprise grade DDoS protection. It has the flexibility to enable protection on an individual public IP resource for around $200 USD per month per IP. It is easy to configure and monitor and comes with MDC and Sentinel integration similar to the top network protection. Let's go over the comparison between these two SKUs. As we can see here, the major difference between these two SKUs is that we do not get the DDoS rapid response support, cost protection, and WAF discount for DDoS IP protection SKU, whereas we have those features for network protection SKU. And all the other features like active traffic monitoring and always-on detection, layer 3, layer 4 automatic attack mitigation, application-based mitigation policies, and other features are all available on both of the SKUs. So let's talk about some of the key features of Azure DDoS protection. So Microsoft's DDoS protection is available in 62 regions and has a mitigation capacity of 80 plus TBPS and can support around 2000 attack mitigations daily. So that includes both inbound and outbound mitigations. So we are utilizing all of the available regions here to reach to the capacity of 80 plus TBPS. So the other key feature we have is the adaptive tuning. So adaptive tuning will help with setting up protection policies turned to your application's traffic profiles. So it utilizes machine learning algorithms. So, to set the mitigation threshold, it can perform dynamic profiling of the normal traffic patterns of the public IP every minute. This profile is then used to predict the expected traffic per the public IP over the next 15 minutes interval time. This is out of the box feature and does not need any manual configuration. So it becomes really easy to set up with no user configuration required. And the other key features we have are the attack analytics and metrics. So attack analytics will help with detailed reports in 5-minute increments during an attack and a complete summary after the attack ends. We can stream these mitigation flow logs to Microsoft Sentinel or an offline SIEM system for near real-time monitoring during an attack. On top of this, alerts can be configured at the start and stop of an attack and also over the attack's duration using built-in attack metrics. These alerts integrate into our operational software like Microsoft Azure Monitor Logs, Splunk, Azure Storage, email, and other Azure portal services. And one of the other major important features that comes with DDoS network protection is that the DDoS rapid response. So during an active attack, Azure DDoS protection customers have access to the DDoS rapid response team, who can help with attack investigation during an attack and also with the post-attack analysis. This team will also help with the custom mitigation policy configuration. So like I mentioned before, this feature or support is only available for the network protection. It's not available in the IP protection. The other notable features here are DDoS SLA guarantee. So basically, we'll get 99.99% SLA guarantee that during attack, the target resource will not be impacted. And we also get cost guarantee, which will give us the service credits for resource costs incurred as a result of documented DDoS attacks. So again, these two features are also available only the network protection. So let's take a look at the pricing for these two SKUs. So for the network protection pricing, like I mentioned before, we have a fixed cost of 3K USD per month for the entire tenant. So it covers multiple subscriptions and VNets. And for any, so this is basically for 100 IPs. For any IP more than 100, we will have to pay extra $30 per month for each IP. So this pricing includes cost protection against unforeseen scale out of resources and also includes the access to rapid response support. Let's take a look at the DDoS IP protection pricing here. So this SKU has a fixed cost again of 199 USD per month per public IP resource protected. So this is the major advantage of this SKU, that we don't have to shell out like 3000 USD per month like the network protection. So if at all any customer has not many public IPs that they need to protect, they can go with this particular SKU and they can save a lot of upfront cost. Let's look at the Sentinel integration section here. So we have an Azure DDoS Protection workbook that is available in Sentinel that can be used to get insights into various DDoS attack patterns in our environment, and that too on a single dashboard. You can get insights about attacks like what are the source IP addresses, what are the countries that we're getting attacked from, top attack vectors, etc. This information will help the security analysts to understand the current traffic patterns in our environment and also for the troubleshooting purposes. And the final integration that I wanted to talk about is the DDoS solution for Microsoft Sentinel. So using this solution, we can set up automated detection and response to attacks using Azure Firewall and Azure WAF. So the solution comes with DDoS data connector, workbook, analytic rules, master playbooks, and third-party playbooks. And it's also currently listed in Marketplace. For more information on DDoS solution, you can always check out our Microsoft Tech Community blogs. We have a couple of blogs published around this topic for automated detection and response scenarios for Azure Firewall and WAF using Sentinel. So this is the brief overview of the Azure DDoS protection. Now I would like to hand over to Saleem for covering the demo part of it. Over to you, Saleem.
Awesome. Thanks a lot, Shabaz. Okay, so let's start with the demo part. For the demo part, we will do it in the Azure portal. And as you can see here, I have it open in front of me. For the demo and deep dive into Azure DDoS protection, I will show you how to create the DDoS plan for the network SKU and also for the IP SKU, show you the difference, how to configure both of them. The configuration in general is very easy because of the adaptive tuning, so there is not that much to configure. However, there's a lot of things to do when you want to investigate, if you want to know like the threshold, look into the logs and also the workbook. And that's something that I will speak about. So if you were, for example, under a DDoS attack, you want to know, if some legitimate traffic was dropped, what was passed through to your workloads, to your public IPs and services, then I will show you now how to do it. So let's first start with our first SKU, which is the DDoS network protection. So I'm gonna go to DDoS protection here. So the DDoS protection plans here. So under DDoS protection plans, this is gonna be only for the first SKU, which is the network SKU. As you can see, we have one created here. Now let me show you how to create another one, which is quite simple. There's not that much to configure. So you see, like here, you can put the specific subscription you want, the resource, for example. Let's go to my resource, resource group, and then here you specify the name. You can give it like DDoS plan test, and then the region. Now it will be deployed in this region, in this resource group and subscription. However, keep in mind that using just like this plan, you can protect all of your VNets or your public IPs under the same tenant. So usually, at least for most use cases, if you have one tenant, then just one plan should be more than enough. And also, if you have like more than 100 IPs, then also from like the price point of view, it makes more sense to have just one plan and protect all of your VNets, public IPs under that same plan. Now, so this is all the information it needs to create the DDoS plan. You can add your specific tags that you're using, and then we will go for the review and creation. For this case, we will not create it because we already have one here. So let me open this one. And let me show you how inside the DDoS plan it works. So under overview, you can see like here, for example, the resource group, location, subscription, and that's mostly it. There's not that much details. Under settings and under protected resources, this is the location where you can add your VNets. Now, the DDoS network protection works in a way that you protect your VNets, right? So all the public IPs that you have under your specific VNet will be protected when you add them to this plan. And let me give you an example. So under VNets, you can see I have a virtual network here. So all the public IPs, resources in this VNet are protected by this plan. And you can see here different resources. You can see like, if I do like firewall, there's no firewalls we are protecting, Azure firewalls. You have application gateway, bastion host, load balancers, and different resources here. And then you can see like, of course, if you have a few VNets, you can see different resources and which ones are protected. Now, of course, like the resources here, specifically, it's the public IP that is attached to these resources, right? And for like, in this example, like let's go, we can see that we have an application gateway, which is protected here, and it has a public IP, which is under this plan. And to add a VNet, it's quite simple. So you go just like this to your subscription resource group, and then you select the virtual network that you want, add it, and all the public IPs under that VNet will be protected. So this is how it works with the DDoS plan for the first SKU. Now for the newer SKU, which is the network IP protection SKU, it has to be done under the specific public IP resource. And let me show you how to do it. For this example, I'm going to use a Bastion instance. So I'm going to go to Bastions here. So this one is mine. So Bastion test DDoS. Let me open it. So for this specific Bastion instance, we can see here it has a public IP address attached to it called DDoS test IP. I'm going to open this one, and from this resource we can see also if it's protected under DDoS or not. So on the right bottom corner, you can see here protect IP address. Let me click on protect, and here we can see the status. So now after this loads up, yeah, we can see three options here. And before going into that, we have the protection status. So the protection status tells you if this public IP has any DDoS protection enabled. And what I mean by this is it will show you if it's protected by your plan or the network SKU, which is the one I just showed you earlier. So if this bastion and this was under a VNet that was protected in that plan, it will show us as protected by network SKU, and we can just leave it as that protection type. In this case, you can see that protected IP is DDoS protected. So this one is specifically the IP SKU, and IP SKU you can enable the DDoS protection specifically on each public IP that you want to protect. And this SKU, of course, it's more it's more useful to use it if you have fewer IPs, right? So if you have, for example, less than 15 public IPs from pricing point of view, and you're not that interested into the extra services like the DDoS response support and the WAF cost reduction. So in that case, or if you have like maybe just one or two public IPs, it could be better to just use the IP SKU protection. And to enable it, basically, and let me show you how to do it now. So let's first disable it, and you can see that it will show you that this IP has disabled DDoS protection and will not receive any protection. So let me save it.
Saleem, sorry to interrupt you. Could you just zoom in? We have a feedback from the audience that it's just
Absolutely.
them. Yeah, thank you.
Okay, is it bigger?
Yes, thank you.
Yeah, perfect. So yeah, I think this configuration looks a bit small. Okay, yeah, now it should be clear. So going back to the configure DDoS protection, you can see that I disable it, and this is disabled, means that there is no DDoS protection. And of course, if you have it on network and it's not protected, it will also it will not show disabled, but there is no DDoS protection for it. So this is the status. This is how you know, and you can validate if you have DDoS protection enabled on your public IPs. In our case, I'm going to put it back under IP protection, so we have it protected against DDoS attacks. And let's just go back here to confirm that and validate that it's protected. Okay, so you can see, so it's green and protected IP, DDoS protected. So this is how you validate that, or how you enable DDoS protection. From point of view protection that you get, there is not that much to configure, right? So once you have this, you already have the adaptive tuning that is doing the profiling for your public IPs based on the application scaling and also the traffic, and you will have a unique threshold for each public IPs, and actually you will have three unique thresholds, one for TCP, one for TCP sync, and the last one for UDP. So this is how you enable it, how you configure it, but this is just the beginning, right? So now we have it enabled. If we were now under DDoS attack, we would be protected. However, we can't see anything, and that's because we don't have diagnostic settings enabled. So next thing to do, so under your public IP resource, we will go to diagnostic settings, and let's make sure that the logging is enabled. And you can see that I have two configurations for logging, and let me open this one. So this is the diagnostic settings for this logging. Basically, I have it enabled for all three categories: the notifications, the flow logs, and also the mitigation reports. And you can see also the metrics. So I have it enabled for all three. I'm sending these logs to our log analytic workspace, and you can send it to different places if you're using, maybe if you want to store it in a storage account, or stream it to an event hub or a partner solution, right? So in our case, we will use the log analytic workspace. So here, I can confirm that I have the logging enabled. So if there was a DDoS attack, I can see the logs and I can also investigate, and I will show you in a bit how to do that. But how can we enforce these settings, right? So how can we enforce that all public IPs we have this logging enabled? And if you want, also you can enforce that the DDoS protection is enabled on the public IP itself, right? So we have Azure policies for that. We have built-in Azure policies, and I'm gonna go to another tab open here. Under this tab, I have the Azure policies. So let's load up in a second. Okay, here we go. So under Azure policies, I'm gonna go to definitions here. And you can do this also the same on your portal. So if you search for DDoS, you will see a few DDoS here, Azure policy definitions. Let me just see the names. Okay, so the one that I was mentioning was virtual network should be associated with a DDoS plan, right? So this one makes sure that all the VNets you have are under a DDoS protection, so that you have all the public IPs protected, and this also can enforce it, right? Now, if I do built-in type, and yeah, so this is the first one. So public IP addresses should have resource logs enabled for Azure. So this is how you do it. Using this definition, you can create a policy that will check your public IPs, and it will make sure that in diagnostic settings, it has the logging enabled and it's sending it to your log analytics workspace. So using this policy, you can enforce and make sure that all the public IPs you have or they will have for sure like the diagnostic settings enabled. And this is also really good for scalability, right? So in the case that, let's say, you enable DDoS, you have free public IPs, and of course in the future, like you're expecting that the organization will add more public IPs. Right now, you don't want to every time to go to the public IP and enable the settings and everything. So basically, this one you can enable it on all the subscriptions that you want, and automatically, or it will enforce that every also new public IP created will have that diagnostic settings, which is sending the logs to your work analytics workspace. So this is how you enable the Azure policies. This is how you enforce that the logging is enabled. And you can also, of course, enforce that the DDoS protection is enabled on your public IPs using the built-in definitions that we have here. So this is the Azure policy. Next, I would like to show you an example of if you were under a DDoS attack, how can you find if the DDoS mitigation started, what time, and also investigate into it, right? So in our example, I did a DDoS attack around 2 hours ago on our Bastion public IP. So let me go back here to the Bastion and this public IP. So under DDoS public IP, this public IP resource overview, we can see here the specific public IP address, right? So 104.40.18.118, and I did the attack on this public IP, and you can see it here. So the attack that I did, or the simulation attack, I used breaking point cloud. I did it on HTTPS on 443. It was a TCP sync flood, and as Shabaz explained earlier, TCP sync flood will send this TCP sync packet, but then it will not reply with ACK, so it will keep the resources open and do the DDoS attack. So the test size was 200,000 packets per second with 8 different source IPs. So the attack was successful on this Bastion host. And now let's look into the investigation and let's see how we can discover the DDoS attack and what happened during the DDoS attack. So I'm going to go back to my public IP address resource. And the first thing we do, let's go under monitoring and metrics. So under metrics, scope, this is our public IP. The metric namespace, you can just leave it as it is. And under metric, we will go down to the bottom. And the first one we will start with is under DDoS attack or not. So this metrics basically shows you when you were under a DDoS attack and when you were not, right? And you can see here, so this is for the last 24 hours. We can see that at least the data starts from here, right? So this is like 3 hours ago. And the reason is because I enabled DDoS protection around this time. So this is the reason why you will see the metrics data for it at this time. And you can see shortly after there was this, it went to 1, and 1 means that the DDoS mitigation was active. So it means the threshold was met, and also there was a DDoS attack and the mitigation was happening. And you can see that it continued here for around 20 minutes, even though the attack was 10 minutes. And the reason is because there's the buffer zone after the attack that the mitigation will continue. Because if there's like another sudden attack, it doesn't just disable it, and your workloads won't be affected, right? And something also here important to note is the Azure DDoS protection is not in line, which means that the DDoS mitigation only starts when the threshold is met, right? And basically what this means is that let's say like right now, the DDoS, you can see it's zero, which means that the packets to your public IP are sent directly. They're not being, mitigated or anything like this. The mitigation only starts after the threshold. And let me show you the thresholds that are done based on the profiles from the auto tuning. So the first one we want to look at is the inbound sync packets to trigger DDoS mitigation. So I'm going to open this one, and this should show us. And you can see also for this one, data starts when I enable DDoS protection on it. And you can see that this is the threshold for TCP sync. The threshold is 20,000 packets per second, right? So if we receive more than 20,000 packets per second, the mitigation starts, and then the packets start being checked by our pipelines, DDoS pipelines, and if it's malicious traffic, it will be dropped. Now, this is the first threshold. We have 3. So this is the inbound sync. There is the inbound TCP packets. And you can see it's 200,000. And the last one is the inbound UDP packets. So this is for UDP attacks. It's 20,000 packets per second also. And this, of course, the threshold is different for each public IP that you use. Even if all of them are under the same plan, it doesn't matter. Each public IP you have protected will have a unique threshold based on the application scaling that is attached to it, the traffic. So now that we saw the thresholds, next I want to show you the DDoS attack, right? So the spike when it was enabled. So I'm gonna go to the bottom here, and first thing I'm gonna look at is the packet count, and here you can see. So for this bastion host, there's not really that much traffic. You can see, like, I'm using it mostly for the demo, but here suddenly you can see that there is a huge spike of 9 million packets. That suddenly, like, it's very clear that this is a DDoS attack, right? And this is the same time as when we saw that the DDoS mitigation was enabled. So the attack that I did was TCP sync, right? Let's go to sync count, and you can see the same thing. And the reason is because the attack was sync packet, TCP sync, so we will see the same type of spike here. And next thing I want to show you is the packets, the total packets and how many were dropped. So if I go to inbound TCP packets, DDoS, so this specific metric will only show when there is a DDoS mitigation active. And the reason is because these are related to the DDoS plan, DDoS mitigation. So in peacetime, there won't be any metrics for this, but you can see it once there is a DDoS attack, and you can see the same thing here. So you can see that it's up. There is 120,000 packets per second for inbound TCP packets, and it's up here. This is when we had the DDoS attack. So I'm gonna keep this metric, and what I'm gonna do, I'm gonna add another one. I'm gonna go down to inbound TCP packets forwarded, right? So forwarded means that these packets were checked by our DDoS mitigation pipelines, and they were deemed as non-malicious, right? They were valid packets, and they were forwarded to the service or to your public IP. So I'm gonna add this one. And you can see that there is almost no, like, there's very small amount of packets that were forwarded. And the reason for this, as you saw earlier, was because this bastion was not really active, right? There was not really that much traffic going to it, so there was not really so much, legitimate traffic. So I'm gonna keep also this metric, and I'm gonna add the third one. So for the last one, I'm gonna go down here to inbound TCP packets dropped. So dropped means that these packets were checked and they were found malicious. So they were, they went through our mitigation pipelines go through the different tests, and they were deemed as malicious packets. And I'm gonna click on this inbound TCP packets, and you can see that it is almost exactly as the first metric we have here, which is all the TCP packets. And the reason is because there was almost none valid traffic going to our bastion. So this is normally what we will see here, that it will match it almost exactly the same. So you can see down here, like, the exact numbers. So in metrics, this is how, if you want to see when you had a DDoS attack, when the mitigation was active, if you wanted also to see like how much of that traffic is, forwarded, how much of that traffic was dropped because it was found malicious, then you can see it here, and you can use these different metrics to check it. So this is for our public IP. So now that we saw the metrics, let's have a look at the logging, and the logging will give us even more detailed information. So the diagnostic settings that I have here, I'm sending all the logs to our work analytics, right? So it's called network security CXC logs. So I think I have it open here. And yeah, in this tab, I have the log analytic workspace. And this is the log analytics workspace where we are sending the DDoS logs. So under logs here, I'm going to close these queries because we have already specific one that we want to run. Okay, so here in the query, I'm going to paste the logging that we want to see. So it's Azure Diagnostics. This is the table that we use, and the category is DDoS Protection Notifications. So if you remember, this is one of the 3 categories that we have for DDoS, and this is the first one that I want to show you. So I'm going to run this for the last 12 hours, and let's see what we have. It should show us also the DDoS mitigation or DDoS attack that we had, that I did around like 2-3 hours ago. So I'm running it. So this is the first category, and I will show you the notifications, and later I will show you also the other 2 categories we have and how you can really utilize them and use them, right? So the notifications, basically, you should have, for each DDoS mitigation or DDoS attack, you should get 2 specifically. There should be one for when DDoS attack started, and the second one when DDoS attack ended, right? And as you can see, we have 4 logs here. So let's start with this first one. And if I go down to the message, I can see that this is when DDoS, the mitigation stopped. So the mitigation stopped for this specific IP. And if you remember, this is the IP that I did the DDoS attack, and it stopped because the inbound traffic is below threshold, right? So the threshold is the one that we could see in the metrics. Now, if I go to the second message, which is actually earlier, it's the first one. So this is also the mitigation stopped, and here we can see the start. So the mitigation started. We'll show you when the DDoS mitigation started for the specific IP that you have, and here we can see also the reason why, which is because it exceeded the infrastructure default threshold and it started, right? So how you can also use these logs is that you can create an alert based on them, right? So whenever there is a DDoS attack and there is this log notification saying, hey, mitigation started, what you can do, you can create a new alert rule, which will, and depending on you can have it SMS or some specific type of work or flow you have, logic app, or an email, right? That sends you an email or sends you a notification saying, hey, there is a mitigation started for this specific public IP. And you can then, of course, monitor like the resources you have behind this public IP during the attack, and also, be aware that there is a DDoS attack that started, right? Or you can also have it like create a ticket if you have like, for SOC or depending on what you have in the organization, right? So this is a way to use the DDoS protection notifications, and you can see here when it started and also when it ended. So this is the first one. The second one that I want to show you is the DDoS mitigation reports. So I'm gonna paste it here. And this one you can see, so where category equals DDoS mitigation reports, right? So I'm gonna run this one. So the DDoS mitigation reports they will be generated every 5 minutes during a DDoS attack. And then after the attack, there will be a one log called post mitigation that will be the one that will show you all the details about like aggregated details about that DDoS attack, right? And you can see like we have a few logs here. And if I open, like, for example, this one, I can see that this is an incremental. So incremental is the one that is every 5 minutes, and it will give you an update about the DDoS mitigation, what's happening, right? So what we want to do, so I'm gonna scroll here a bit to the right, and I'm gonna look for report type. So I'm gonna look for the other one we have, and we can see it here, post mitigation. So I'm gonna open this one. And what I'm gonna do, I'm gonna filter just using the post mitigation because I wanna look. So since now it's after the attack, basically I just want the information aggregated in the same log, right? And actually, I'm gonna look for the last 24 hours because I think there was also another DDoS attack that I want to show you. Yep, here we can see. Awesome. So this is the first one that we have. This is the one that I did earlier. And let's open it. Let's get some information. So after a DDoS attack, right, you need a report about what was happening during this attack, from where it was coming from, what kind of attack vector, and details like this, right? So I'm gonna go down here. You can see here that this is for this IP. This is the targeted IP address. Under the attack vectors, you can see what kind of attack vectors were used, like TCP sync flood, other packet flood, and TCP flood. And this is the type of attacks that I did because of the TCP sync. It also triggered TCP flood. Then we can see the traffic overview. So traffic overview will show you all the packets, and in this example, you see that there's a huge number. And the total TCP packets dropped, you can see that it's very close, this number, and the reason is because the bastion didn't have any real traffic going through it, right? So most of it was just from the attack. And going down, you can see different type of traffic. Here we can see like the protocols, the drop reason, so why it was dropped, and you can see here protocol violation, invalid TCP sync. And basically what this means is that because of the attack, TCP sync, the bots that started the attack, send the TCP, didn't respond to the TCP sync that was like from our mitigation DDoS protection. And since they didn't respond with the act, then it was seen as a protocol violation, invalid TCP sync. And these packets, of course, didn't reach the public IP, so that didn't use any resources on your side. Then other than this, you can see also like the top source countries, like from where it was coming from, and top source countries for dropped packets. So which was the malicious packets, right? You can see United States and China, and for the dropped packets mostly United States, ASNs, and also the continent. So this is the attack that I did earlier. If I'm gonna let me close this one, and let's look at the other attack. So the other attack here was on this public IP. And if I go down here, what I want to show you, so under traffic overview, so this is the total TCP packets. You can see it's a huge number, but you can see that the amount of packets dropped was a lot less. And the reason is because there was legitimate traffic going to this resource, and the DDoS mitigation only mitigated the malicious traffic, and not, of course, it wasn't dropping also valid traffic. So this is this is the DDoS mitigation report for this specific IP. The last Azure diagnostics that I want to show you will be the mitigation flows. And mitigation flows has the most details, and also you should be careful with the mitigation flow logs. And let me cancel this one. So you should be careful with DDoS mitigation flow logs because it can generate a lot of logs. The reason is because it will log each packet that goes through that goes through your public IPs when there's DDoS mitigation active. So what I'm gonna do, because if I run this, there's gonna be like more than 30,000 or 70,000 packets, more than that. So I'm gonna limit it. So I'm gonna here I'm gonna limit it to 500. So we have a good sample. So I'm going to run this one. So basically, this is going to run the this category, and it will limit it just to 500 logs. And you can see here, so we have the logs. There's going to be a lot of logs here. So first thing, I'm going to scroll a bit right here, and I want to look at the message. So let me go back a bit here. So these are the logs, and if I go down, and you can see it here. So under message, you can see that this specific packet, which is coming from our source IP, this is the source IP, source port, and this is our public IP and the destination port, right? This is from the attack. You can see it was dropped because of the protocol violation and valid TCP sync. And of course, here in the flow logs, you will be also able to see packets that were forwarded, so legitimate traffic, right? And to do that, I'm gonna add the extra filter here. So under this one, we're just gonna run where message equals packet was forwarded to service, right? So this is the packets that were legitimate, were forwarded to the public IP. And you can see that we have a lot of packets also for that. And if I open one of them, you can see like this was deemed as a legitimate traffic and it was forwarded, right? So basically what you can do with these logs is that after, let's say DDoS attack, there was one specific service. That service, there were reports that it slowed down, or it was unresponsive, and you wanted to confirm, hey, is this related to that DDoS attack or not? If it was at the same time, right? What you can do, you can go here. You can, for example, look for that specific public IP, or that public IP and also the port, and you can, for example, go to the destination port here and include it, right? So I know it's packet related to this, so I'm gonna also include this port, and I'm gonna run this again, right? And basically here, then you can start looking. So I'm gonna also remove they forwarded, so we can see also the packets that were dropped. So I'm going to look for this port. I'm going to try to look and see if there's anything that was dropped, but it shouldn't have been dropped, because we know that it's legitimate traffic, right? And using that, you can look at the logs here, and you can see that. So this is an idea of how you can investigate it, or if you want to look how you can also add some KQL like here filters, and you can look for that specific traffic flow that is, for example, from a specific service that you have running, and you want to make sure that, hey, the DDoS didn't drop any legitimate traffic, or if you want to see how much of the malicious traffic was dropped. So this is how you do it in the logging. Now, this is all of this is for the same public IP. What we are checking here, is for the same public IP as the destination, and we're not really looking at different public IPs. Or if you have maybe let's say 10, 20 public IPs, all of them are under DDoS attack, it's quite difficult to just to go specifically here in the logs and check one by one, right? So a solution for that is that we have a workbook, and I'm gonna go so from Log Analytics Workspace, I'm gonna go down here to the workbooks, which should be under monitoring, and yeah, workbooks. Click OK here. And basically this workbook is available in our GitHub, so you can deploy it from there instantly. And it's called Azure DDoS Protection Workbook. I'm gonna click on this. This workbook aggregates all the public IPs that you have under specific subscription or subscriptions, and that are getting the logging data from your specific workspace. So the one that we were using is network to security CXC logs, and I'm gonna keep the time range to last 90 days in this case. And public IPs you can also select here, so you can see there is public IPs. I have selected all, but for other specific reasons, maybe you want to look for your specific public IP and just filter by that. And so what you can see here now, let me remove this. This gives us the view about the overall DDoS mitigation traffic for all the specific public IPs that we have aggregated all in the same location. And you can see like, the traffic overview. So all the packets, how many were dropped, TCP dropped, UDP dropped, and also other packets and the amount of other packets that were dropped. On the left here, this is all the mitigations that happen, all DDoS attacks. And you can, for example, like you can see that this one was the biggest one, last one. You can click on it and then you can just filter, like look at this specific attack, and you can also, create a report based on this attack, right? So this workbook, makes it easier for you to, share a report to the leadership and show like, for example, the DDoS attacks and, how they were mitigated. And now, so for this example, let me try to get this screen a bit bigger, so maybe you can see all the numbers. So here you can see like the protocols that were used, like 78% was TCP, the continent of origin from where the attacks were coming from. You have the countries of origin where the attacks were coming from, also the AS numbers, if you want. And then also the drop reasons, right? So why the packets were dropped, because maybe of protocol violation or other reasons. And then here you can see like the same data just shown in different format. And then here we have like raw DDoS mitigation logs, which is what I showed you. So, with this, this is probably the best way if you want to look at, DDoS reports. We have 5 minutes left, so I think this should be it. So I showed you in this demo, just quick recap, how to create the plan, how to create the DDoS IP SKU, enable logging, use and enforce Azure policies on your IPs, how to view the metrics, how to view the logging and investigate them, and then of course how to look at the aggregated data in one report and use DDoS. So I hope you found it useful. Next up, I'm gonna give it back to Valen to see if there is any questions that we want to address.
Thank you. Thanks to both of you for covering this great topic, as DDoS indeed continues to be a top security concern facing many customers out there moving their applications to cloud. So this was great presentation and demo. As far as questions, well, we have a team of SMEs here that were tackling the questions with all the answers, but we can surely surface a couple of them since we only have 4 minutes left. So the first one goes, which resources are covered by a cost guarantee? Is it just the DDoS itself or any resources behind the public IP all the way down to databases and storage?
Yeah, that's a good question, Valen. So it's not just the DDoS, and it's not all the resources, right? So the specific resources, I will also provide a link where you can see them. But an example would be like, if you have a like, let's say, application gateway, right? So application gateway scales out because of the DDoS attack. Then you're paying, of course, extra for that, right? So this is extra in court, cost that you can get back if you have it, of course, documented. Another example also there, would be like, for example, if you have some specific Azure, workloads behind that public IP, then it's the same thing, right? So for anything, any scaling out, you get the credits back, right? So maybe like the best way I think to answer this question is I will provide the link to the pricing where all the resources are mentioned, and then can be checked there, like which ones are included.
Great, that will be great. Then the next one is, what is the minimum threshold on the number of requests in order to identify and prevent an attack?
The minimum number of thresholds. So We so there is a minimum threshold, of course, because we can't have it, too low. Like, we can't have it just at like 5,000 packets per second for UDP, for example. I don't think we can share the exact number, but there is a minimum that is for the threshold, and it's pretty low. So I think most applications shouldn't be considered as under DDoS, if it's not lower than that. But yeah, there is a limit, but I don't think we can share the exact number for that.
Okay, great. This gives us some time to wrap it up here, and a few more questions came in, but they're all themed around the pricing, which we already answered, and the deck will provide some of the answers to that with the resources that you gentlemen provided. So thank you, Shabaz, Saleem, for being our guest today and for sharing the great information with our public community. Also, thank you to the Q&A team who helped us with answering the questions and providing these resourceful informations. And to all the listeners out there still on the line, if you're someone who wishes to aid in the protection of the world from cyber threats and or DDoS attacks, and desires to have a say in shaping our strategies, blueprints, and recommendations, then we invite you to become part of our security community, because together we can make a global impact. So please join us at aka.ms/security community. This is also a place where you'll be notified about the upcoming webinars, events, and other announcements. Also, please take a minute submitting your webinar feedback at aka.ms/security webinar feedback. Obviously, today's topic was DDoS protection with Azure Network Security, and that product should be listed under there. So please provide your feedback. For those of you who may have additional questions on the topic that we just covered or other product related questions, please feel free to raise them on our Microsoft Tech Community discussion space area at aka.ms/ANS community. Thank you all for being part of our community and for joining us on these webinars. We hope to see you next time. Goodbye.